cases. We have to use this equation of amplitude in different cases, right? Now we know that when we consider two waves, at that time these two waves have different phase angles or different phase differences, right? Now it means the value of phi changes. From 0 it is 90, it is 180 and so on, right? Therefore, when the phase angle between two waves is different, at that time we have to find out what happens to this amplitude. What happens to its amplitude, right? Now we consider different cases. Now we consider here special cases. Special cases. Now we consider first case. Now we consider first case. Now in this case we consider, suppose when phase difference phi is equal to 0. Now we consider when the phase difference phi is equal to 0. Now phi is 0 and the phase difference phi is 0 means cos of 0 degree is 1. Cos of 0 degree is 1, right? Now we have to find out the expression for resultant amplitude, right? Now we know that what is the expression? A for resultant amplitude, A is equal to under root A1 square plus 2 times of A1 A2 cos of phi plus A2 square. Cos of phi plus A2 square. But in this case, what is value of phi? Phi is 0. Therefore, cos 0 and cos 0 is 1. Therefore, we write here A is equal to under root A1 square plus twice A1 A2. Twice A1 A2 and cos 0 is 1. When it is multiplied by 1, now it is 2 times of A1 A2 plus remaining A2 square. Okay. Now when we solve this, now it becomes, it is nothing but it is the A plus B bracket square is equal to A square plus 2AB plus B square, right? Now see this, right? Now therefore it is A plus A2 bracket square. This is nothing but it is A1 plus A2 bracket square. Now left hand side is A. Therefore when we solve this, A is equal to A1 plus A2. Therefore A is the resultant amplitude, and resultant amplitude A is always equal to addition of these two amplitudes A1 plus A2, right? Now again in this case we consider, suppose if A1 is equal to A2, what happens? When both the amplitudes of both the waves are same, at that time what happens? When A1 is equal to A2, at that time A is equal to 2 times of A1 or it is 2 times of A2. Means the amplitude get doubled. Amplitude get doubled. But when it doubled, at that time, now we know that when phase difference between any two wave is 0. Now we write here, if phi is 0, if phi is 0, the amplitude of wave is maximum. Amplitude of wave is maximum. Means when the phase difference between two waves is 0, phi is 0, at that time what is the amplitude? Amplitude of wave is maximum amplitude. Okay. Now this is the condition. When the phase difference between two waves is 0, at that time the amplitude of that wave is maximum, right? Now come to the second condition. Now the second case. Now when phi, now initially the phi is 0. Now suppose we consider phi is not 0 but it is 180 degree. It is 180 degree. Therefore when angle of phi is 180 degree, therefore cos of 180 degree is always minus 1. Cos of 180 degree is equal to minus 1. Therefore we write here A equal to A1 square plus 2 times of A1 A2 cos of phi plus A2 square. Value of phi is 180 and cos 180 is minus 1. Therefore, it is written as A1 square. Now it is minus 1. This total factor becomes negative. Now it is minus of 2 times of A1 A2 plus A2 square. Right? Now again when we solve this, now it is written as A1 minus A2 bracket square. And again when we solve the square root, now it is A1 minus A2 and the left hand side is A. Right? Therefore, the result when the phase difference phi is 180 degree, at that time the resultant amplitude A is always equal to A1 minus A2. The difference between these two amplitude, right? A1 minus A2, right? Again, if A1 is equal to A2, if A1 and A2 are same, at that time what happens? At that time A is equal to 0. At that time A is equal to 0. Means if the phase difference between any two wave is 180 degree, at that time its resultant amplitude is 0. And when resultant amplitude is 0, it means that at that time amplitude of wave is minimum. Therefore, we write here, if phi is 180 degree, phi is 180 degree, amplitude of wave is minimum. Amplitude of wave is minimum, right? Now from this it is clear that now the resultant amplitude of two wave always depends upon this phase difference, right? When the phase difference is 0 degree, at that time the resultant amplitude A is always equal to 2 times of its amplitude. Means at that time this resultant amplitude of wave is maximum, right? But when this phase difference is 180 degree, at that time its resultant amplitude is always equal to 0. Means when angle phi is 180 degree, amplitude of wave is minimum, right? In this way we study the different cases. Means angle between two waves, right? Now from this it is clear that now we know that intensity of wave. Now intensity of wave is denoted by I. Intensity of wave is denoted by I, and magnitude, amplitude of wave is denoted by A. Now between intensity of wave and amplitude of wave there is one relation. What is the relation? Intensity of wave is directly proportional to square of its amplitude. Means if I is the intensity of wave and A is the amplitude of wave, at that time I is proportional to A square, right? Now using this relation we consider two different conditions, for minimum condition as well as for maximum condition. Now we consider first case. For phi equal to 0, means when the phase difference between two waves is 0. At that time, what is the relation between intensity and amplitude? Now when angle phi is 0, at that time we consider I max. I max means I max is proportional to A max, and A square means A max square, right? But when it is A max, at that time it is equal to A1 plus A2 bracket square, right? Therefore, I max is proportional to A max square, and when it is possible, at that time for A max square, it is A1 plus A2 square, right? From this, it is clear that when this intensity of wave is maximum, now when intensity of wave is maximum, when phase difference between two wave is 0. It is A1 plus A2 bracket square. Okay. Second case. Now for phi is 180 degree. Phi is 180 degree. When phi is 180 degree, at that time intensity which is minimum, and I minimum is proportional to A minimum bracket square, and this A minimum bracket square is equal to A1 minus A2 bracket square, right? In this way, when the phase difference between two waves is 0, at that time intensity of wave is maximum, and when phase difference phi is 180 degree, intensity of wave is minimum, right? But again it is clear that now when we are to study the intensity of wave, it is clear that intensity of wave is maximum. Intensity of wave is maximum when two waves interfere in phase. When two waves are interfere in phase, means intensity of wave is always maximum, but when the two waves interfere or superimpose in phase, right? Now this is the first point. And second, intensity of wave is minimum. Intensity of wave is minimum when two waves interfere out of phase, in phase and out of phase. What is the meaning of in phase and out of phase? Now we know that intensity of wave is always maximum, but when, what is the condition? When two waves interfere in phase. When two waves are moving or traveling in phase condition, at that time intensity of wave is maximum. When two waves are out of phase, at that time the intensity of wave is minimum, right? Now this intensity depends upon when the waves are in phase or out of phase. Now what is the in phase and out of phase? Now in short we draw here. Right? Now we consider two axes. This is y axis and this is x axis, right? And this is the origin, right? Now from this origin, this is one particle, it vibrates in the direction. Okay, wave is traveling. Now this is the first point. Now this wave is traveling. Okay, now this is the first point. Wave starts from this point. Now this wave starts moving in this direction. It reaches to this point. Again 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 it reaches to this point. Therefore, this wave when travel through that medium, at that time it reaches at different times on its mean position, right? Therefore, this is the mean position of that particle, right? Now this first particle start in mean position, right? Again return vibrates in downward direction. Again return back to its main position. At that time, this point and this point. Now we consider this is the first point, second point, third point, fourth point, fifth point, and sixth point. Now we consider here how many points are there on this mean position. 1, 2, 3, 4, 5, 6 points are there, right? Now this is the first particle which vibrates vertically in upward direction. Again return back to its main position. Again vibrate in downward direction and return back to its mean position. At that time, when this particle vibrates, at that time it completes its vibration, and after its completion of one vibration, initially the particle is here, after that it reaches to this point, right? Therefore, this point 1, the particle vibrates in upward direction. It reaches to this point number 3, and at this 3 number, again this is the second position of second particle. This energy is transferred to the second particle. Now again this second particle, 3 number particle, start vibrating in upward direction, right? Therefore these two particles 1 and 3 are in the same phase. 1 and 3 are in the same phase, or it vibrates in the same state of motion. It vibrates in the same state of motion. Therefore, 1 and 3 are known as same phase particles, known as same phase particles. Again, at the same time, again this wave reaches to this point, again this particle vibrates in this direction. Therefore, 3 and 5, these particles are also in phase particle. Therefore, 1, 3, 5 are in phase. Therefore, we consider here the particles at 1, 3, 5 are in phase. Right? Now, all remaining particles. Now, this second, fourth, sixth, these are not in phase. Therefore, we say that 2, 4, 6 are known as out of phase. Known as out of phase. Right? In this way, 1, 3, 5 are in phase and 2, 4, 6 is known as a out of phase. Now, again, these two particles are also known as a in phase particle. Again, these two particles are also known as in phase particle. Therefore, when now first particle of first wave and second particle of second wave, when these two 1, 3 are interfere with each other, at that time we say that there is in phase. When 2 and 4 interfere with each other, at that time we say that it is out of phase. In this way, now the intensity of wave is maximum when the two waves interfere in phase, and intensity of wave is minimum when two waves interfere out of phase. Now, in this way, today we discuss principle of superposition of waves. Principle of superposition of waves. Then we find out two expressions. First expression for the resultant displacement of wave, it is y, and we find out second equation. This equation is the amplitude of resultant wave. Right? Now write down the assignment. State and explain principle of superposition of waves. State and explain principle of superposition of waves. Right? Okay, now we stop here.